Hi, Steve King here. Well, today I'm going to be using PixInsight to show you how to use a noise reduction technique that's not commonly used, but it can produce some rather extraordinary results. It's called surface blur noise reduction, and I learned it back when I was first doing astrophotography processing, and I looked at some tutorials by Doug German, and he had one showing how to use this technique. And so I learned how to reproduce the technique in PixInsight and sometimes use it when I have noise that's just difficult to get rid of. So it really only addresses noise in the darker parts of the image, but that's usually where you have the biggest problem. So let's go ahead and get started. By the way, I have a set of icons, which if you look at the information underneath the video screen in YouTube, there's a link where you can download these icons. Okay, with that out of the way, you start out by making 2 copies of this image. By the way, before I get started, let me just show you what we're dealing with here. I hope you can see this. There's just mottled noise, blue and red, just a lumpy background in general. Even little brighter areas are kind of mottled. So this is what we're hoping to eliminate and get down to a cleaner looking background than what we have here. Okay, so with that in mind, we make 2 copies. One small letter O for original image. Put that over here. And another one called B for blurred. Now I've already done some work on a B, so I'm going to just leave this one right now as SHO clone. And let me show you what you do with this image. You open up the clone stamp process. Let me zoom in. I set the radius to 250, that's close to the maximum, and the softness at 0.81. So when you use the clone stamp, it'll feather the edges of the area that you stamp so you don't get sharp, abrupt edges. And what we want to do is clone stamp out all of the bright areas of the image and just leave alone the darker areas. So we'll leave it alone areas like this here, down along here, down over here, the areas along here, up the side. These areas we'll leave alone, and we'll clone stamp out these bright areas. So let's select a spot that's nice and dark up here, and then we'll put that over, and we'll use that to start cleaning up some of the brighter nebulosity. So I continue like this, just starting in one place and then working my way along, clone stamping out the brighter nebulosity. And when I get finished, okay, let me remove this now. I was just showing you how you go about doing this. And by the way, if you have some couple bright stars like this, just get rid of them. You don't have to get rid of all of them. You just don't want any really bright stars around. Okay, so that's what we're going to do. So let me close this. Close this clone. And here is what I ended up with after I finished getting rid of all the brighter areas. Let me go back. So here's the original. And I left the areas of low nebulosity and just blotted out the brighter ones. Once you've done that, then you open up the convolution tool. Let me zoom in on this. And just set standard deviation at 75, and the other two are standard values. Shape 2, aspect ratio 1. And then we drop this onto the image where we've had it clone stamped and let it blur it. There you go. So we now have our blurred image. We have our original image. And then you open up Pixel Math. Let me zoom in. It's a pretty simple expression. It basically says if the original image is greater, in other words, brighter at any pixel than the blurred image, then you put in the original image. Otherwise, you put in the blurred image. This other thing, N, allows you to adjust this adjustable threshold that varies around the blurred image. As where it's brighter, the threshold's higher. Where it's darker, the threshold's lower. But this allows you to adjust the amount of noise reduction by raising the number n. N is located over in the symbols. It starts out at n equals 0. Usually you don't have to change it more than plus or minus 4 to get the result that you want. Take this destination-wise, it's going to create an image called NR, noise reduction, noise reduced. Okay, so we just simply hit the square apply button, and there we get NR. Okay, so let me close this. Let me compare them this way. Let me zoom in a bit. So this guy over at the edge looks pretty mottled. What's it look like in our noise reduced version? Nice and clean. Let's go over to this side again. Pretty mottled. Clean. Up to the top. Top left corner. Mottled and clean. Let's look over at the top right corner. Some blue modeling there, and clean. If we zoom in a region like this here, what do we see here? So it's pretty much unaffected. So the brighter areas are left alone, but it cleans up the dimmer areas. So it's quite a handy tool. Let's look at some regions like here where it's kind of a transition area. So really, everything looks fine. So the darker areas have been cleaned up, the brighter areas have been left alone, and you end up with a very nice image. You don't want to raise that value of n any higher than it has to be, because it will start removing low-level nebulosity if you do. And it can start making the edges of a nebula look rather scraggly. You don't want that. So, I hope this has been useful for you. The purists sometimes don't like this technique. They say, well, you're just cutting off noise and throwing it away. And I guess all I can say is, yeah, I sure am. And if I don't see the noise, that's okay with me. But, you know, if it bothers you, then you won't use it. And if you like the results, then hopefully it works for you. Okay. Thanks for looking.